Welcome to this week's Tango Talk. I'm Dick Hancock, reliability consultant with 24/7 Systems in Knoxville, Tennessee, and our topic is going to be a best practice in reliability information management, and that best practice that we're going to focus on today is tracking both location and equipment reliability information. Let's give a brief review, though, of what these best practices are and why they're important. If you're focusing on asset reliability using things like condition monitoring, reliability analysis, etc., you will most likely have two major goals you're trying to achieve. The first is a shorter term, I call it the week-to-week, month-to-month operational goal, where you're trying to use that information coming out of your condition monitoring activities to understand asset health so that you can eliminate failures in service and not disrupt production, cause higher maintenance costs, and cause production losses. A second, longer-term goal is more involved in using the analysis of the suite of reliability information, where you're trying to understand root causes of failure so that you can take steps to mitigate or eliminate those root causes, and thereby reduce the overall equipment lifecycle owning and operating cost and increase business profits. When we talk about reliability information, we're talking about a very wide range of information. If you think about it in terms of what happens during the overall life cycle of any individual asset, and by that I'm talking about whether it's rotating trains of equipment and the individual components thereof, the motors, the pumps, the gearboxes, agitators, etc., or if it's structural equipment, piping, tanks, or if it's standalone equipment, things like transformers and electrical distribution systems, circuit breakers and MCE panels, those kind of things. Then there's a volume of information that begins at birth when that piece of equipment is purchased, and whether it goes directly to a service location in the plant or is stored in equipment and spares or stores inventory. There may be things like the initial purchase information, including warranty and design and installation and operating type parameters that are pieces of information. Even while it's in stores, there may be certain tests that are being done, things on periodic maintenance or such as offline motor test on motors that are in stores, or maybe even just the replacement of desiccant packs in the warehouse on a monthly or quarterly basis to keep condensation from causing problems. At that point, pieces of equipment go to installation, and this is where we're going to spend most of our time today when we're talking about best practice number 3. And there's a variety of things, vibration analysis, infrared thermography, oil analysis that are part of the condition monitoring suite of technologies that you might be implementing, whether it's through direct employees or service contractors. There may be equipment notes that are being taken during walk-around inspections, and out of that, you're developing histories of both locations and pieces of equipment. And that's what we're going to focus on in our talk today. But again, in that life cycle, even then when your condition monitoring activities, for example, spot a developing problem and follow it to the point that it's determined that a maintenance work order is needed to replace or repair that equipment, and then it goes out to repair, there's information that's being generated, what the repair shop personnel find at teardown and inspection, repair actions that are taken at the shop, and there's an opportunity right there to have that repair vendor begin that process of documenting what their suspicion of root causes of failure may be to feed back into the loop, because in many industrial pieces of equipment, that asset may repeat this cycle many times during its usable life. And then you're generating information, as we talked about, to meet that second goal in terms of reliability analysis, where if you've accumulated it in a retrievable manner, you're able to understand which failure types are happening most often, costing the most, what individual types of equipment or individual locations are costing the most, that kind of thing, all the way to the point that a decision is made that that piece of equipment is no longer serviceable and it needs to be scrapped. Because even once it's scrapped, the fact that that piece of equipment served in your plant is a valuable library of information that can help ongoing reliability efforts. And what we're talking about is that, unfortunately, far too many organizations that I still see today in 2020 are focused on generating lots of data and reports and individual pieces of information, but they tend to be islands of information. They tend to be separated, not shareable easily with all of the stakeholders in the plant. In many cases, there's no standardization on the reference to the service locations or the individual serial numbers or tag numbers of pieces of equipment. As I said, they're islands of information that it's very hard to put them all together so that you get a holistic look at the health of an individual asset at any point in time. And then furthermore, another result of that being in islands of information is it's much harder to provide consistent, reliable communications and therefore accountability for things that have been decided on repair actions or root cause mitigations. And without all of that in an easily retrievable location, it's very hard then to obviously have anything to analyze if you don't have the data or the information to work with. And many people will say, well, isn't that what my CMMS does? And unfortunately, in real practice, while the CMMS systems obviously are very powerful, the big enterprise asset management systems like SAP and their notification modules or Oracle or Maximo, in most cases, these have been controlled by IT, and they have been absolutely designed to use my term, to count the beans in maintenance, track the number of work orders that are out there, how many man hours are billed against each work order, what parts are needed for certain repairs, even managing the tool crib that's there, but not for really taking care of the maintenance priorities and reliability information versus that accounting approach. Furthermore, many of the systems that I've run across today still are not built to the component level. They may have a machine train level where they're talking about a condensate return pump machine train, but they don't go down and start tracking information at the individual motor or individual pump level. Some do, but even then, sometimes that is very hard to retrieve at that level. And once again, with that, the biggest issue we find is that it's the CMMS systems tend to be work order related. They're managing the business of maintenance, the accounting side of it, more than the reliability information, and therefore it makes it more difficult and time intensive to get any useful reliability metrics out of those systems. So, as I said, we're talking about practice number 3. We're going to focus on why it's important to track both location and equipment reliability information in separate inventories today. The first two are kind of common sense. To meet all of the obstacles that we just discussed in the previous slide, it makes a lot of sense to be able to accumulate all of your appropriate reliability information in a single database so that it makes it more easily retrievable. And the second topic, best practice that we talked about 2 weeks ago, was focusing on manageable information, not raw data. What the maintenance organization and the reliability activities need to see isn't all of the detailed squiggly lines in vibration analysis, for example, the FFTs, the waveforms, the trend plots. What they need to know is what that vibration technician analyzed, what he determined that information or that data was telling him and that needed to be acted upon. When it became a developing problem, steps as that problem increased in severity, up to a point it was time to begin a serious discussion about the appropriate maintenance action. So today we're going to talk about both location and equipment reliability information and the need to track those as separate inventories. So what does that really mean? If you think about the location, one thought process I found makes it easier is just think about the base plate on that rotating equipment train, or the electrical center, that one MCE location and the components, all the buckets that might be inside that particular MCE. And this is actually where most of your condition monitoring activities occur. To do vibration analysis, you don't have to be terribly concerned about which 150 horsepower AC induction motor is sitting on that base plate in service turning that pump. You're doing analysis on the motor that's in that location on the day that you run that vibration route. And you can be very accurate in understanding condition without knowing a whole lot. Of course, the more you know about the individual details of that motor, the bearings that are in it, the more accurate your analysis can be. But you can do that against the location, the base plate location. By comparison, equipment in my nomenclature is where I'm talking about a unique individual, a unique tag numbered or serial numbered motor, pump, or gearbox that might be in one location on one base plate today. Perhaps it has a problem and gets sent out for repair, comes back to the plant in 2 months, it goes into a store's location, and when it finally is pulled back into service 6 months from now, maybe it's going to go into service on the base plate beside the one that it came from today. And the question becomes, as problems as repetitive problems in particular start to develop, if I have both inventories of information, what's happening with the condition health of a particular base plate location and what's happening with an individual tag numbered piece of equipment, I have the ingredients that I need to be able to start to make differentiations about a bad actor piece of equipment, a component, a motor, a pump, that's taking its problems from location to location versus a bad actor base plate where it didn't matter which motor I put in service there, I was going to suffer a short mean time between failure situation. And again, if you don't have both of those and you're trying to reach reliability conclusions, particularly in terms of root cause analysis, you're really tackling the issue half blind. So let's talk in location-based information. Like I said, it's any information that's coming from walk-around inspections, like basic operator care, lube tech routes, mechanical or electrical calibration inspections or checks. Whether it's any condition monitoring that's being done, such as vibration analysis, oil analysis, and the rest of these things that are on the screen, all of that can be associated against that location. And you can be successful in achieving particularly that first goal that we talked about of eliminating failures in service by simply focusing on the location-based information. And you'll typically see that as the first step. For example, in the system that we produce here at 24/7 Systems, Tango, there will be a functional location tree that will take you down from a unit level to a functional service location level to the asset or machine train level, all the way down to the individual components, such as an MCC bucket, a motor, a pump, tank, a piping run, and you'll be able to do that condition monitoring activity against that location level in Tango. On the other hand, when you're talking about what kind of information is in the equipment-based inventory, you're talking about, number one, probably not tracking every individual piece of component equipment in the plant, but the critical repairable equipment inventory, those things that are most crucial, because you are in fact taking a much closer look and documenting more details than you are at the location level inventory, because you're looking beyond the nameplate and design information to being able to compare what's my overall inventory? How do I look at these individuals and find critical spares that have replacements that are available in case I do have an unexpected outage? I'm going to be tracking equipment documents that are very specific to that individual. And more importantly, I'm going to be tracking warranty information, whether it's a new purchase or a repair situation from a service vendor. In today's world, where we see a lot of high efficiency motors being bought with extended warranties, maybe up to several years, and yet we hear time and time again that once that piece of equipment gets into the plant and it's in a store's location or it gets into a service location, and in the urgency of taking care of maintenance activities in a non-reliability oriented process, I typically don't have the information at my fingertips to understand whether or not this motor, for example, might be being sent to a repair shop when in fact it's under warranty. And we see that people are paying lots of money on what should have been warrantable repairs, and because they just didn't have the information at their fingertips. Again, and the lower line that we're looking at here is talking about the information that you're developing over the service life of that piece of equipment. You're looking at the what's happened. Where has that individual motor or pump served over the 8 years that we've had it in the plant? How often? What's the MTBF on that particular individual pieces of equipment, and has it varied by the different locations? And you can also include how effective have my vendors been. Can I spot a repair vendor that's doing a better job at meeting my standards and delivering repaired equipment that delivers longer MTBF versus one that's delivering not so good MTBF? So let's get right down to it. Let's take a look at an example of how tracking these two different inventories, the set of functional service locations and the history of that location versus the individual pieces of equipment that are serving in those locations and how they work together. And so rather than stick with a PowerPoint, I'm going to change over to a dynamic database. It's the Tango system that is offered by 24/7 Systems. And here we have a demo database that we're using that, in fact, this information really comes from one of our customers that's been using this for a couple of decades. They had been tracking about 3,000 critical motors in their metals plant back from the middle 1980s using a home-built system that the reliability engineer had put together. And when they realized that it wouldn't make it past the Y2K issues back in 1999, they actually helped develop the Tango system and became the library for that equipment and location history that they had been tracking. And what I'm showing you now is one dashboard. It's the Integrated Condition Status Report. And we want to focus on the third item. The first three items all have a high severity issue that has been derived from a variety of condition activities. In this case, walk around visual inspections on the cranes, an electrical online test on this fan in the carbon plant, and a pair of technologies, infrared thermography and vibration, on this motor in a cooling tower surface. And we're going to look at the one that has the combined technology information from infrared and vibration to look at the details of what's going on with this system. And again, this is a horizontal motor driving a cooling tower pump. We see that the vibration call was a high level severity. This is old data since it's in a database, but he suspects a drive-in bearing failure and recommends that the motor be repaired or replaced. He also noticed that there was a problem and that some monthly cleaning should be done. Well, we can see that this work has actually now been completed in this case as of July 31st, according to this. And there's the data in the vibration system that was used to justify the call, the findings and recommendations that have been posted. But when we go down to the issue that was generated by the infrared thermographer, he definitely found that there was an issue causing a buildup of heat, a clogged cooling fan end, and definitely that motor needed to be cooled and kept clean. So again, those were the details of that particular case. And in fact, this dashboard, for most of the customers we deal with, is a very useful tool in their semi-monthly review meetings between maintenance planners, reliability technicians and engineers, and operations in making determinations about what the priorities ought to be on the work order scheduling. And let's just say in this case that even though I'm seeing this current case of that motor had clogged cooling fan ends and perhaps has been the reason that we developed some bearing failure problems, maybe I want to get a little more history. And again, this is just to show you how, because all of this information is against this location called the 101 cooling tower unit. The tower functional service area, the cold well asset, and the motor number one base plate. And if I look at the location hierarchy on the left by locating in tree, we're going to see that in fact this cold well has not just one motor, but it has a motor 1, motor 2, motor 3, all the way to a motor 6 base plate. And I can tell in Tango that this is not only a functional service location for motor number 1, but that we also have information about the individual motor that's currently in service on this base plate, and it's tag number 1452. But if I want to start seeing the history, I can quickly bring up the information about the location. Again, I'm looking to find out what's happened on this base plate over time, and I see I've had a very wide range of days down to a very poor 35 days of the first service installation of a motor before it had to be removed and replaced with tag number 3591. So the first time this was tag number 1449, it lasted 35 days in this location. I then went to tag number 3591. It lasted almost a year. Then I went to tag number 1758, and it only lasted 42 days. I'm seeing a significantly low mean time between failure on these particular motors on this cooling tower cold well location until I get out to installations that are later in life, number 11 and 12. And if I want to see that history, here's the details rather than looking at a bar chart. And I see that I only had the one that's installed is still there because this is a demo database. It's a very large number of years. But I had, back in 1995, we had a single day and a motor. This would have been a repair problem or an installation problem where the motor wouldn't come up to speed. Prior to that, in June to May of 1995, I had a motor that, it was installed in 93, removed in 95, and it was tag number 1450, so it lived a couple of years in this location. So clearly this location has seen a lot of motors come and go, but they're not the same motor. They're very, in many cases, number 1450 has come back to this base plate, but in fact, many other tag numbers, it looks like at least 4 or 5 other tag numbered motors have also served in this base plate and typically suffered a low mean time between failure. So now that's what the history about that location is. If I want to start seeing what the individual motor history is, since 1452 has served several times on this location, I can look up that equipment history by going to equipment reports, equipment history. And now I get details. In this case, for example, all of these motors have been around 350 horsepower, needing a frame size, a 509 UPD frame size to fit the base plate easily. And this is the other documented information that we're tracking. But once again, I see that 1452 has had short service life, short to mean time between failure until later on in its history. And if I start to go down to the details, I see the red rows being the repair stage of life, and the green row being an installation. So let's just go to 1984. Keep in mind, right now we're looking at the motor number 1 base plate that 1452 is on. Back in May of 1984, I see that was on the motor number 5 base plate, right here. If I continue down further, again, I start to see that there's a significant case of pump rebuilds, replacing reconditioned bearings, bearing failures, reconditioning bearings again. When I finally get down to repair, let's see, in 1989, it was on motor base plate number 5 again. It was pulled out of service in 98, May of 98 for repair. And now when I look at the repair documentation, we see where they were getting a better job done by their motor shop to give them more details in the common database about what faults were found and their opinions of which ones were just resulting effects and potential root causes. And now they finally started to see that in this cooling tower location, they'd had repetitive failures where they had shorted windings and grounding problems that led to drive-in bearing failures due to, most likely, water entering the lubricant. So the answer is they needed to do something, either shielded bearings or better environmental containment in that cooling tower location to keep that repetitive root cause from causing that low mean time between failure. So once again, this is a combination of looking at the location history and the individual history of the different motors that are serving in that location and finding the commonalities so that you get a head start on helping understand and confirm location. If you're not tracking and having the ability to pull that information from those two sources easily and quickly, then it's probably not going to happen. That analysis, it might be a good idea, but it may be the thing that no one ever gets around to. And once you're doing that, again, you get that ability to get the details and actually start to look at a much better picture of both the, for example, not the one I want, let's see. I'm just going to go up here. I start to find across the board, if I want to look at everything, we're going to look at the entire plant here on an equipment tracking report. We're going to look at equipment history analysis. And we'll look at, in this case, we'll look at AC induction motors. I'll review a report. So let's see, I want to go down to the actual data. I'm having a lot of drive-in bearing failure, groundings, etc. So lubrication, although moisture and number wet is within my top 10 failure modes that I'm tracking. So I start to find a lot of the details and what I should perhaps be tackling as part of my mitigation efforts is taking care of these wet and moisture intrusive locations that are causing short mean time between failure. As you saw, I think I can also, if I go back to that same report, I can filter and look at location repair costs. The one we just looked at was looking at being able to look at motor types. Now I'm going to look at location cost, and I'll be able to see which locations over time are costing me the greatest amount. So my very top number is a big number, $573,000 on this chip asset. I'm not sure what the NCRSH stands for. It's an AC induction motor, but that guy is costing me a lot of money. And once again, I can go to the individual reports and see the entire history of both which motors have served in this location. I can then look up the individual histories of those motors. And again, what I'm trying to do is to keep my antenna up and spot the reasons for these repetitive failures that are causing the large dollar expenditure so that I can make intelligent decisions about the right actions to take to mitigate them. So in a nutshell, we believe that it absolutely deserves to be best practice number 3 for reliability information management. Make sure that you're tracking both location, history, and separately you're tracking the individual piece of equipment history and developing the information to be able to use both of those inventories to help you make better reliability decisions. Okay, with that, next time we're going to be talking about moving into the area of how to really be efficient in managing all of those condition-based monitoring tasks that are being done and how to make sure that you're getting the right things covered on the right kind of time intervals that you're expecting to be done. So keep an eye out for the email notice on the date and time for reliability information best practice number 4, and we look forward to seeing you then. Thank you.